morning, but it looks like a good group of people here. So what I'd like to do is, let's see, let's get these slides moving. I'm sorry, the delay. Got it? Okay. What I'm going to do is just talk a little bit about technology, just what's going on technology, and I'm going to keep it with FM radio right now, not AM, not TV. Just we're talking about FM, what's happening. Those of you that know us probably know a little bit about our equipment over the last few years with BTSI. If you have time, come see us in the exhibit area and ask any kind of questions about the technology I'll talk about. The area that we come from is pretty much the Silicon Valley in Italy, and it's a land of art and technology. So in this area is Ferrari, Maserati, and a lot of the famous composers and things come from this area. It's a really beautiful area and really a high-tech environment. What I'm going to talk about is the areas that specifically that the trends in FM are heading in this direction right now. Not particularly for just us, but we feel we're a leader in this area in small type of equipment, smaller. Everything's getting smaller. I remember when I entered the industry, this simple 2-rack unit was maybe the size of 2 or 3 refrigerators, but now it's just small. The technology is getting smaller. So the benefits we see in cellular phones and other things we're starting to see in size of the equipment. But there's more to it than that. A lot of this happens due to what we call this planar technology. Now, how does the planar technology really help us? It's in a lot of ways. It just doesn't reduce the size of the equipment, but also the planar technology keeps the equipment running cooler. It means there's less parts, less failure. When we do something in a factory, there's not a lot of assembly anymore. You can do a lot of the RF techniques. You can do it right in the board. And so the grand result is longer life for products and lower price, which everybody likes. The next thing we'll talk about is direct-to-channel. And this is the exciter technology. And we have traditionally analog type exciter technology, analog for analog technician. But what we've done pretty much is gone over to a direct-to-channel DSP exciter. And what that basically is everything in a programmable array device. It's a chip where everyth's done in software, not a lot of discrete components. Again, you have a lot of more durability for the equipment. The equipment, it's less expensive to produce it, but a lot of the audio performances are improved drastically going to direct-to-channel. So we're moving over into a full production of digital exciter technology direct-to-channel by next year. And I think you'll see a trend to this. This also paves the way that as we go into some of the digital technologies like HD or whatever, there's 3 or 4 different technologies that are being used worldwide. This is the first step. We have to do something like this first. So with that digital technology, you'll get a lot of things built in like RDS. There's a lot of things you might have with your phone like the GPS capabilities and so forth. So what we've done is over the last 5 years, we've really honed a technology, what we call our core technologies, and the first being IceFET. And with IceFET, it's, there's nothing to do with ice or snow or anything like that, but what we've done is we've tried to lower, RF equipment and amplifiers can get a little bit warm, and over the years, this is the thing, is to make sure that your transmitters don't overheat. So what we've done is we've overspecified on our power amplifier devices. And we basically run them at approximately 60% of their potential. And by doing that, we're able to save the life of the transmitter, but more importantly, we get the temperature down. So we're going to run at about 40 degrees centigrade instead of, in the past, you might see something up to 60 degrees, very hot. So this is the IceFET technology. I can explain a little bit more how it works with the smaller transmitters or the larger ones, but the next step being the eco savings. And this is a big area. This idea mainly came out of in Europe, where the price for the diesel, gas, and generators, and all the electricity was very expensive. So what happened was they developed how can we save more money, more efficient equipment. So we really go for a green technology for operating our equipment. So today, for example, the tube equipment would run at maybe about 50% efficiency or less. Today, the solid state equipment is running 75% efficient. And this is a big savings for your operating bill. Now, if you're specifying equipment to your bosses, or if you're looking at what's being specified, you can look at, oh, here are the savings I can do in operating costs. So the technology is saving us money in our electrical bills. It's a big deal. Life Extender is a technology. We incorporate all the software together. Life Extender, what this does, it's a very complex algorithms that measure the temperature of our equipment and how to run our fans. So we can control the speed of 6 fans, for example, in a transmitter. And if things get a little bit hotter, we can run the fans a little bit quicker, or we can cut back if we don't need it. We also allow you to be able to set up a program where we can run 25% of the transmitter power, or 50%, 75, or 100%. So the whole idea there is when you don't need the full power of the transmitter, cut it back. And by using that life extender, it's going to increase the life of the product. Everybody wants to have transmitter devices that stay around for 10 plus years. Now, if you can wait for the technology, things are moving so quickly, 10 years might not be enough. So, these are typically, at times in the past, these were added features, but now they've become standard. Now, this is an exciting area that, I really enjoy this, and that we're developing two things going on here now, is that there's so many software hooks in our equipment that we measure 300 plus different points. We're looking at voltages and currents and RF points and so forth. So let me, if I get the pointer here, I'll explain to you some of the screens here. But basically, we put a combination of test equipment and operations and schematic manuals into the equipment embedded. So if you look at this, I'm trying to get this pointer to work. On the far left, during an installation, or if you're going to check out the RF performance, I can look at from the spectrum, what does the spectrum look like, and through my diagnostics. Do you have a pointer by any chance? It's not working. Okay, well anyways, on the left, this is for installation or for monitoring from the RF point of view. The middle picture might be something, this is a schematic. So not only am I looking at what alarms I might have on the equipment, where, I see red, yellow, or green. Here I have a full schematic, so I can look at, here is the module, and you can see in that lower left that that's a power supply that's under alarm. On the third one, this might be the screen that I might want to design to put together to look at the critical things in operating the station. I have 5,000 watts or 5 kilowatts running forward and 0 reflected power. So this particular display is would be done on, say, a 5, 10, 20, 25, or 30 kilowatt transmitter, and you could put a touch panel 52-inch display on the front of the rack. So whenever you want to look at it, everything is there to look at. Although it's not needed, you could also look at this remotely on a computer. Now, the other thing with Watchdog is what we've done is put together a program, which will be coming soon, that allows our local in-country representatives who are trained by us to be able to use Watchdog. So if your staffs are becoming smaller for RF people to manage the equipment, what we can do is we can have our local in-country people, in this case it would be TSI, could look at the equipment and see all these screens and be able to look at problems before they happen, or be able to diagnose and see exactly what's going on. So we're going to do the Watchdog for you if you need it, or you can do it yourself. If you have a whole network of 10 or 20 different stations, you could do this yourself. There's actually another picture that we can look at specifically in a full network by the entire country. You can look at what's happening. They asked me to speak for 5 minutes originally, and I can't even keep it down, so I'll try to move on here. The other area is important. Being in Asia, and we run into a lot of problems with what we call the dissimilar metal problems, where we get corrosion just simply because we have higher humidity. And there's a couple of things you can do. You can run your environment with dehumidifiers or other things, but we do everything in this particular design. Everything is aluminum, so basically you're going to not see corrosion, and corrosion affects the circuits, corrosion affects the mechanical parts, and so forth. So we've spent a lot of work in this area. So that's it for the technology, the basic areas, things that are coming, and things that are here today. And I'll be over there